Alright, so problem number 5. We have an island which is 2 miles out into the water at a perpendicular distance from the shore to a point P. So that's point P right there. And then 12 miles down the straight coast, we have a town. And then we want to know if a person is rowing a boat from the island, where should they hit the shore in order to minimize the time it takes to get them to town? Because it takes them 3 miles per hour to row, but they can walk for 5 miles per hour, so they can walk more quickly. So we want to know what is the most efficient way to get to the town. So we need to think about this real quick. Notice how we've labeled X there. Well, if that's X, then this distance on land that the person is going to have to travel right there is going to be 12 minus X. But we also need to know the distance that they are traveling through the water, this dw. So we need to do a little Pythagorean theorem because this is perpendicular. So I can say that dw is going to equal the square root of x squared plus 4, which is 2 squared. Cool. So now I need to write myself an equation for time. So let's think about this. Let's go time t equals, well, I know that the time is going to equal my speed, and it's also going to have to do with, wow, I'm talking like a crazy person. Okay, let's start writing this and see if that will make words come to my mouth and brain better. So, a person can walk 5 miles per hour. Think about what we want in the end. In the end, we want to minimize the time. So I want my time units to be in my numerator. So instead of writing this as 5 miles per hour, I'm going to write this as 1 over 5 hours. Whoa, hours per 5 miles. 1 hour per every 5 miles. And you'll see why I did that in a moment. So 1 hour per every 5 miles. That sounds weird to say. I keep saying it weirdly. But that's how fast the person can walk. And to represent the distance the person's walking, that's going to be 12 minus x. And we need to add to that time the amount of time that it takes the person to row to their destination. And again, our units here were miles, and so the miles and the miles cancel out, and we get just our units of hours. So let's go ahead now and look at the other part, the water part. So in this case, our speed is going to be in 1 hour, we can go 3 miles. So I'm setting it up the same way. And now let's go ahead and multiply that by our distance, dw, which is the square root of x squared plus 4. And now we want to graph this. But again, let's figure out a domain. Well, a good domain is going to be an x max of 12 and a min of 0. And then I'm going to zoom fit to find my y scale here, y being my time, because that's what we're graphing. We're graphing a time, how long it takes us given different x values. So let's enter that equation and see what happens. Remember, if you're on an 83, use a lot of parentheses. So if you do a zoom fit, you get a window that looks a lot like that. The y maximum there is just about 4. It's a little over 4. And we want to calculate that minimum value. So again, second, calculate 0, 12, guess anywhere, and it tells you that the x value, where you have a minimum, is 1.5, and it looks like the minimum time, again, time is our y values, the minimum time is 2.933, and again, our units, we were talking about hours. So the minimum amount of time it could take a person to get there is just about 3 hours.